Okay, the last thing we stopped with was problem number, I think it was 35, and we completed it. Again, the picture that's provided over here is better than the pre-calc sketch I gave you. But again, when you take calculus, your graphs will be refined to look better than the ones we're presenting to you here. All right, so we're going to go back to the whiteboard, and I'll start with the problems again. All right, and we'll finish this up today. So give me 1 second. And let me take a look at this. All right, and we're going to start with problem number 36. And let me just blow it up a little bit, and we'll start doing it. All right, so this one, if I was asked to do this problem on the exam, the first thing I would do is I would add 5 to both sides. I want to get that absolute value. What would you get over there? Something pretty simple. You get the absolute value of 14 minus 3x is greater than 3. Now, what does that mean? Well, reading it, it means that 14 minus 3x must be greater than 3, or 14 minus 3x must be less than minus 3. All right, let's see if we can solve that. And pretty simple. I'm going to say 3x, adding 3x to both sides, and subtracting 1311. And I'll put an or over here, finish that one later. And this one over here, I got 3x. I'm adding 3x to both sides, and I'm going to add 3 to both sides, get 17. And then I'm going to divide through by 3. I get 11 thirds, or divide through by 17 thirds. And I put my number line down. I can get those numbers correctly placed. So there's 2 numbers. They're fractions. One is 11 thirds, and the other one is 17 thirds. Let's read it. What does it say? X is, what does it say? X is less than 11 thirds. All right, I'm reading the first one. This is below it. And what's another one? X is greater than 17 thirds over there. So I got my intervals. What's going to be? Minus infinity up to 11 thirds, union 17 thirds off to infinity. Those answers are also listed for you there. Let's go to the next question. Write the linear system represented by this augmented matrix and determine what x, y, and z are. And I can do that pretty easy. And I'm going to just make sure you understand that they asked me to do something. And this can be x minus y plus 2z is equal to 4. The second line is just y minus z equals 2. And the third equation is z equals minus 2. All right, so I wrote it down. I did the first step. And it says use back substitution to figure out the solution to the problem. Well, I got one answer. And I'm going to go backwards, see if I get the other one. What's the other one going to be? Y plus 2 is equal to 2, which means y is 0. I'm going to go backwards, put it up here. What do you get? X. Well, if y is 0, that's minus 0, which is, I'm not going to put that down. And 2z's would be minus 4 is equal to 4, which means x is equal to 8. All right, let's see if we got this. I'm seeing that over here. I got that written down for you. X minus y plus 2z is 4. Y minus z equals 2, and z equals minus 2. Let's see if we got the right answers, though. Z is minus 2, looking pretty good there. Y is 0, looking good over there. And x is equal to 8, looking great. All right, let's do number 38. Number 38 is a condensation. And that means I'm going to try to write a shorter expression if I can. And it looks like a lot of work, but let's put this down. All right, so I'm going to put down 1/3. I'm going to work inside the grouping symbol first. This is ln x plus 3 squared plus ln x minus ln x squared minus 1. All right, let's keep going. And this is going to be 1/3. And let's see, ln, this is going to be x times x plus 3 squared over x squared minus 1. That's not so bad. I got that covered. And now I know this is 1/3 on the outside. It really means a cube root. So I'll write this over here. This is going to be ln cube root of x plus 3 squared over x squared minus 1. All right. We're staring at that answer right there. Hopefully that's pretty easy to do. All right. So it says, given the following graph, it's on page 104, answer the following questions, and I've got to look at it. All right, so I'm not looking at that graph yet. I'm going to go to that graph. I'm going to the next page. I'm looking at it, and make sure I'm looking at the right graph. They said, given the following functional graph, answer the following questions. Is it invertible? Explain your answer. Let's go back to that. Let's look at this one over here. And I'm going to say it's not invertible. And I'll tell you the number one reason it's not invertible. I can find a line that hits it twice. All right. And that's what's known as a horizontal line test. Let's go back and let's take a look over here. And I see the answer right over here. It says no, it fails the horizontal line test. Got that covered. Here's the next thing. It says graph this thing. Well, let's go back to what you have to do, right? And I want to emphasize what you have to do is you've got to look at this guy over here and come up with a table. Let me write the table down for you. And the table is going to be the points, right? So I'm going to put the points down for you. And the first point I see is, this is going to be x. This is the parent, f of x. And the first point I see is minus 4. And that's going to be what? Minus 4, 2, right? And then what do I say? Minus 2, right? That's next point I see, 3. What's next point I see? Let's see, looks like 0, minus 1. And the next point I see is going to be 4 minus 2. Now someone says, what do they want me to do? They want me to graph twice, right? F of 1 minus x over 2 minus 1. All right. So, question is, I got to look at the graph. I can't remember what those points are. And we're trying to encourage you to look at things. And by looking at things, hopefully you start to realize what they want you to do. So they want you to graph it. So what do they want me to graph? They want me to graph a child. And I want to tell you what that child's going to be. The child's going to be twice f of 1 minus x over 2 minus 1. And yeah, I know it's tough. It's a table problem. And I'll put the table down for you. And I want to graph this guy. Right? I want to graph him out. Let's put this down, see if we can do it. And I'm going to put this down as a table. X. And I'm just going to call this guy over here Y. All right. So I got to do it. What are you going to do? Well, when does 1 minus x over 2 equal minus 4? I got to solve that. Minus x over 2 would be minus 5. Minus x equals minus 10, or x is 10. That's done. Let's do the next one. 1 minus x over 2 is equal to minus 2. Minus x over 2 is minus 3. Minus x equals minus 6, or x is 6. I'll write that down. Let's keep going. I'm on a roll, right? 1 minus x over 2. Well, the third point was 0. So it's minus x over 2 equals minus 1. And then it's going to be minus x equals minus 2. So x is 2. That's done. Let's do the next one. 1 minus x over 2 equals 4. Minus x over 2 equals 3. Minus x equals 6. Well, x is minus 6 now. Well, let's keep going. Now let's write this down now. 2 times f minus 1, 2 times f minus 1, 2 times f minus 1, 2 times f minus 1. Let's plug in 10. What do you get? 1 minus 5, which is minus 4. Let's do 6. 1 minus 3, which is minus 2. We'll look at the numbers later. Let's do 2. You would get 1 minus 1, which is none. Let's do minus 6. What would you get? 1 minus a minus 3, which is going to be 4. Okay. What's f of minus 4? It's 2. I'm looking at this up here, by the way. That's going to be 4 minus 3. I'm sorry, 4 minus 1, which is 3. What's f of minus 2? It's 3. That's going to be 6 minus 1, which is 5. Let's keep going. I know it's tough. Boy, that's going to be f of 0. What's f of 0 minus 1? That's going to be minus 2 minus 1, which is minus 3. Okay, What's f of 4? It's minus 2. 2 times minus 2 is minus 4. Minus 4 minus 1 is minus 5. Okay. Look at the key. All right. What's key going to be? Looking at the points. Let's take a look at that. I see this point, 10, 3. 6, 5. 2 minus 3. And minus 6 minus 5. But they did ask me to graph it. Now, granted, I'm not very good at drawing pictures. I'll do my best job. 10, 3. What's that going to look like? 10, 3. Maybe over here somewhere. That point's done. 6, 5. Right about there. All right. 2 minus 3. Maybe right about there. Minus 6 minus 5. Let's see. Minus 6 minus 5. Maybe about there. How they connect together? Line segments. All right. What do? They give you a key, they give you an answer to the key, and they actually draw a nicer picture than the one I've drawn. The reason for that, the machine is doing that picture. All right, let's keep going. And again, we're just looking at pictures, evaluate the expression if possible. This is a simple multiplication problem. I want to tell before I go forward in this thing, do that, the dimensions of this thing over here, and this is 3 by 2, and this is a 2 by 2. The result of this thing is going to be a 3 by 2. All right. What does it mean? 3 row, 2 column. All right. So let's take a look if we can do it. And I kind of remind you what we're doing over here. So it's going to be minus 2. That's pretty easy. And then what do you get? Oh boy, minus 3. I'll write the return side and 54, right? That's going to be 51. Okay, let's keep going. And let's do the next one. Let me just cross that out. That's going to be minus 8. That's pretty easy. And then what do you get? Let's see, minus 12 and 45, right? And what's that going to be? 33. Let's cross that out. And to the next one, it's going to be 0 and 0. That's pretty simple, 0. And then what do you get? 0 and 27, which is 27. Check the answer key, and I can't say it enough times to you. Please do that. Minus 2, 51, minus 8, 33, 0, 27. All right, sketch the graph. Let's look at number 41. 41 looks like a relatively simple question. I know it has something to do with an exponential problem. I want to point out the parent function f of x would be 3 to the x. What do you see over here? Well, 3 to the x is a pretty easy graph to put down. And what I mean by that is you've got a graph that's fairly simple. 3 to the x looks like this over here. All right. So someone says, what's the child look like? It's going to be 2 units, right? Shifted, right? 2 units shifted to the right. I can make a table up for you. Before I do that, though, I'll put this point over here. And what's this point going to be? Well, that point there would be, let's see, that would be, if x is 0, that would be 9, right? Right. Now, if you shifted that over 2 units, what would it be? 2, 9. So what I expect to see a point 2, 9 on the curve. All right. And let me just take a look. And I got to make sure I'm doing the right graph for you. I'm just looking at my notes over here. Sketch the graph. All right, let me take a look. I meant 2 units to the left. I'm sorry. I misspoke. 2 units to the left. So that's really that would be minus 2, 9. I'm sorry about that. It's 2 units to the left. 2 units to the left. All right, let's graph it out. Little table down for you. And let's put that down. So minus 2 would give me, let me see, minus 2. Let me put this over here. By the way, this is parent. This is child. X, and this is going to be 3 to the x plus 2. So if I chose minus 2, what do I get over there? 3 to the 0, which would be 1. All right. And let's take a look. I'm sorry, I just did another mistake. I just saw it myself because it's not making sense. I'm thinking backwards here, and I got to erase this over here. All right, made a mistake. And I'll tell you what I'm doing. I just wasn't even thinking. If this is 0, this would be 1. And that's making sense to me now. And what do you get over here? You get this picture over here. All right, that's what you get. At 0, what would you get over here? You get 9. That's what I said before about this picture. This would be 0 and 9 here. And this is over here. This is going to be the point minus 2, 1. Shifted 2 units to the left. Sorry about my confusion there. It happens sometimes. I doze off or something. All right, let's go to the next question. And that's going to be, number 42. And that doesn't look too bad to do. I'm going to blow it up a little bit. And I would like to look at the problem and see if I can do it without too much work. And the first thing I notice is I'd like to get in the same base. So I'm looking at it. I'm looking at the 81. And I don't see any 2 in it, but I do see a 3 in it. What would that be? 3. And I'm looking at it's going to be 3 times 3 times 3, 3 to the 4th, right? And then what do you get? You get 16, which would be 2 to the 4th. And what would that be? That would be 3 halves to the 4th power. I'm getting warm. And this is going to be 2/3 to the minus 4. Now I'm starting to see it. What am I seeing? X is minus 4. All right, relatively simple. Right. Are there other ways to do those problems? Of course there are. However, most people would need a calculator to do it, but you could take natural log of both sides. Let me write that down for you. If you have 2/3 to the x equals 81 over 16, if you took the natural log of both sides, you'd have x ln 2/3 equals ln 81 sixteenths. I think this is far more complicated, by the way. X would equal, let me write this down, ln 81 sixteenths over ln 2/3. Yeah, I'm not opposed to doing it this way, but let me keep going. This is ln 81 minus ln 16. Geez, it's a lot of work. ln 2 minus ln 3. Let's keep going. We'll eventually get there, by the way. What's this going to be? Well, it's 81 is, 3 to the 4th power. So 4 ln 3 minus 4 ln 2 ln, did I do a mistake over here? 2/3, yeah, ln 2 minus ln 3. Boy, this is so much work, it's incredible. Factor 4 out, what do you get? ln 3 minus ln 2. Factor minus 1 out, you get ln 3 minus ln 2. What's nice about this? Cancels off. What are you left off with? Minus 4. Did we know that? Of course we did. We did that in the beginning. I find this to be much easier to do, but you could do it by other methods. All right, let's go to number 43. Relatively simple question. And again, I appreciate when they're simple because it's easy for me to do it without much thought. All right, so it's going to be x plus 6 minus 2x minus 2. We have an answer key too, by the way. This would be 4 minus x over x plus 1. Number line goes down. On the number line, put my zeros down. The bottom becomes 0 at minus 1. Top becomes 0 at 4. Test it out. Between minus 1 and 4, 0 is a good number. Plug it in. You'd have 4 divided by 1, which is positive. Positive numbers are not less than 0, so that's going to shade in. Take a number after 4, like 5. You get negative over a positive, which is negative. Certainly a negative number. That's gets shaded in. Take a number below minus 1, like minus 2. Plug it in. You get positive top, negative bottom. Overall, negative. What's my answer? Minus infinity to minus 1, union 4 to infinity. All right. What do I want to recommend you do is please look at the answer key to make sure that you can agree with the answers that we're giving you. And then certainly the answer is listed for you. So let me just see if I go to the next page and do problem number 44. All right. So number 44, again, they want me to solve it algebraically, exact answer, which is really what we do in exams. Approximate, can you use a calculator? Well, let's go through it. So what do I see over here? I see 2 ln 3x equals, well, I'm going to add 2 to both sides, which would give me 19. ln 3x equals 19 halves. 3x equals e to the 19 halves. X equals e to the 19 halves divided by 3. All right, I want to point out the answer is listed for you right here. All right. If you're going to use a computer to do that, which you should learn how to do that, it's going to look like this over here. You're going to have e raised to the power 19 divided by 2, then divide by 3. Now again, some calculators need to put a decimal in somewhere. And if you did this, you should get this number over here. And if you're not getting that number, bring it to our attention. Let's go to number 6, determinant. Couldn't be easier. If you remember how to do it, that is. If you don't remember to do it, it's not going to be easy at all. What do you get over here? Let's write this down. Minus 1 times, well, I'm going to do the determinant of that. That's just simply 9, submatrix, minus 2. That would be 0. That was easy. Plus minus 5. And the submatrix there is, wow, 0 again. That couldn't have been easier. What do you get? Minus 9. All right. What are you answering? Minus 9 there. All right, let's look at number 46. More challenging, isn't it? So let's go through it. They give you a function. They want to know the answers. And the answers, what are the x-intercepts? Well, the x-intercepts when the top becomes 0, provided the bottom is not simultaneously 0. And that would occur at 1 and at 2. And those are listed for you, pretty simple. Y-intercept, what do you do? Set x to be 0, you get 2/3. Pretty simple. All right. Equation of horizontal asymptotes. I want to put the work down for you. I'll write down for you. Limit as x goes towards infinity. Our recommendation is to divide by the highest degree variable, which is x squared. You would get 1 minus 3 over x plus 2 over x squared. And on the bottom, you get 2 plus 5 over x plus 3 over x squared. Well, if you think about it, if x gets really large, those fractional terms go to 0 and you're left off with 1/2. If you did this one over here, really same story, divide by the highest degree variable. We just did that. We need to do it again. Now we're dividing by an incredibly large negative number. And again, if you give it some thought, those fractions are going to disappear, get 1/2. So what do you get? Horizontal asymptote, y equals 1/2. The verticals, more challenging. I know that. It's where the bottoms are becoming 0. In this particular example, x equals minus 1 and x equals minus 3s. It's a little bit challenging for students with the limits, but I'm going to talk about that. I'm going to talk about by doing the graph of it now, right? Because I did say do the graph. We'll look at the graph later, and I'm going to just pull it over to the side, and I'm going to put the graph down for you now. So give me a second. Take this, pull it to the side, and we'll look at this thing later. And I'm going to put my graph down now. Whoops, didn't mean to do that. Okay, so hopefully you can remember what you've done. All right, now what you've done is you've got some points that you got, and I'll put the points down for you. One of the points is at 1, and the other point is at 2. That's nice to know. All right, I got a y-intercept at 2/3. All right, 2/3. Put this over here. All right, 2/3. All right, what else did we find? We found that we had a horizontal asymptote at 1/2. Okay, I found that. And now I think I found anyway that the vertical asymptotes, right? And one of them occurred at -1. I'll put that in for you. And the other one occurred at -3/2. I'll put that down for you now. All right, let's connect it together. And, by connecting things together, it's basically sign analysis. And I'm going to just quickly go through it with you. And the reason for quickness is that you should be quick at this point. You should have a really good idea what these pictures look like. So if you want you to write a 2, like if you took a number like 3 and plugged it in, everything would be positive. So I'm going to say I have a clear idea that this thing is going to be doing something like this over here. All right, clear idea about it. Okay, I'm going to go below -2. I'm going to go to like -3 and plug it in. You'd have, negative times a negative on top, which is positive. On bottom, you'd also have, negative times negative, which is a positive. So a pretty good idea that, this thing is sailing towards this thing over here. All right, here comes a problem. It's positive. So what do I know about it? It's going towards that vertical asymptote. So I'm going to say maybe something like this. Someone says, why can't it go down? There's no place to go through. All right, let's keep going for sign analysis. Now let's go between, let's see, 1 and -1. And I clearly know the sign of it there. It's positive, so it's got to do something like this. Okay, let's keep going. Let's go between the 1 and the 2 and 1.5. And I have a negative thing, so I know it does something like this. All right, this is pre-calc sketch. Oh boy, I got a problem now. I got a number between -1 and -3/2. So let's say -1.1. And I'm going to say positive on top. And on bottom, it would be negative. Oh, I got something like this now. It's got to be negative. Going towards the asymptotes. I'm going to write my limits down now. Limit as x goes towards -1 from the right of f of x. Limit x goes towards -1 from the left f of x. Limit x goes towards, what's that other number we got? -3/2 from the right of f of x. We'll write these down by looking at my picture. This can be helpful when you come to calculus, that you'll be able to do these limits without looking at tables. All right, let's take a look. And I want to point out what I'm looking at. I'm looking at this, -1 from the right. This is -1. This is the right. I'm going to say positive, plus infinity. Let's keep going. -1 from the left. I'm going to say negative infinity. We did that by sign analysis, by the way. All right, let's keep going. -3/2. That's this line over here from the right side. This is right side, minus infinity. Let's keep going. Whoops. Sorry about that. -3/2 from the left side is going to plus infinity. I'll put that down for you. Again, if you look at the key, you'll see those answers, and hopefully those answers are pretty easy to look at. All right, let me just go back. And I think I did this one. Let's go to 47 now. And 47, use graph and algebra to do it. And first of all, I think you probably know I like algebra. So let's write this down. 2x plus 2, that's y. And y is also x squared minus x minus 2. What do you get over here? X squared minus 3x minus 4 equals 0. x and x. Let's see, 4 and 1 minus plus x equals minus 1, x equals 4. Got my 2 points, and it's going to be minus 1. And minus 1 would give you a 0. I'm using the second equation to do that. And the next one's going to be 4. Now it would be 8 plus 2, which is 10. Got my 2 numbers, 2 points of intersection. Let me graph it out, because I did say algebra and graphing it. And I'm going to do the line first. This is the line I want to do. And that's going to have a x-intercept at minus 1 and a y-intercept of 2. Let's do the parabola. And a little more complicated, isn't it, parabolas? I know it's got a vertex somewhere. Before I do that, I want to factor it. Let's put this down. Y equals let's see, at minus 1, a point there, and a 2. And the parabola, again, I'm not saying it's a terribly accurate picture, but minus 2 over here somewhere. So maybe something like this over here. I know that point of intersection is pretty obvious. This one, there's no way I could read it from my really bad graph, but I hope you can agree that that would be 410. Again, look at the answer keys, and certainly I give you a much better picture, and I give you the points, and that covers it, right? We're done. Thank you.